Okay, some questions about increasing momentum, and I think the best way to illustrate this is if we consider a golf ball sitting on a tee, and we're going to hit it with a golf club. Now we've talked about follow through with swings and things like that, and one of the reasons for that is that we want the ball in the club head here to be in contact with each other for as long a time as possible. And we'll get to why that is. Okay, but first, let's just get a few things out of the way here. PI, that's the initial momentum, MV, of the ball, is what? When it's sitting on the tee? 0, right? PF, well, that depends on the ball's mass and on the ball's final velocity. So let's say the mass is 0.1 kilogram and its velocity is 100 meters per second. So that's pretty fast, but let's say 0.1 kilogram times 100 meters per second equals 10 kilogram meters per second. So that's the final momentum of the golf ball, all right? So what we would do then, since we know the initial momentum and the final momentum, remember, momentum is just mass times velocity, we would want to find the impulse on this ball. What is its change in momentum? Well, if it started there at 0, we want to go PF minus PI here. So PF minus PI. If it started at 0, then we're going to subtract 0 from the final momentum. So 10 kilogram meters per second minus 0 is going to equal 10 kilogram meters per second. Okay? So we just calculated the overall change in momentum, or the impulse. Now, the question is, what do we do if we can only swing this club and hit the ball with 100 newtons of force? Can we get the ball to go farther than what we would? Well, let's see. The impulse is equal also to the force that you hit the ball with times the amount of time that the ball and the head are in contact with one another right there. How long are they touching? If we say that the impulse is 10 kilogram meters per second and the force we hit with is 100 newtons, then what is the time of impact? Well, let's do some division. Divide both sides by 100 and we end up with 0.1 seconds. That's the time of impact. That means that the ball and the club head are touching each other for 0.1 seconds. Well, why do we follow through then? If we follow through, what if we just can double that impact time instead of just slapping the ball and letting the ball run off? What if we try to hold that club head on the ball, or tennis ball on the tennis racket head, something so that the impact time is increased? If we double the time of impact, all right, what would happen to the overall momentum of the ball? Well, it would double also, because here we would have a force of 100 newtons, but instead of multiplying by 0.1 to get 10 kilogram meters per second, we'd be multiplying by 0.2, twice as much, which would give us 20 kilogram meters per second. And since we haven't changed the golf ball's mass, the velocity would be twice as much. Now, it's not easy to increase the club head ball contact time by 0.1 to 0.2. That's very difficult to do, but if you were to be able to do that, you would essentially double the velocity of this golf ball. What did we say the velocity was? 100 meters per second. It would become 200 meters per second. So without hitting with any more force, the force you hit the ball with is still 100 newtons, but if you double that impact time, you hold that club head on the ball longer, if you double that impact time, you would end up with double the velocity. So without any more force, just a follow through, you can hit the ball with much more velocity.